of ways that this key phrase shows up, but it just says right here, set up an expression involving an integral for the area completely enclosed by these functions. So what does that mean?
You don't have to go any farther.
You don't have to, yeah, you don't have to like get the answer, right? You just set up the expression with an integral or integrals and you call it done, right? So like if you wanted to, you could use the calculator, you could use some Math 9 stuff, or you could maybe do it by hand too. But in no way are you going to be required to actually get kind of the final answer here. I do suggest, though, using the calculator to help you understand what these graphs look like. So if you would, just take a minute here, plug these, f of x and g of x, plug them into your calculator. Let's see what they look like. And we'll talk about what this phrase, area completely enclosed, we'll talk about what that means here in a second. So yeah, please do get that graphed. Did you guys get a graph kind of like that?
Yes.
Okay. So, when we talk about completely enclosed, it appears, I suppose, you can tell me what you think, it appears to me that we're talking about this orangish region that I'm trying to highlight. Does that look about right to you guys as far as the region we're trying to find the area completely enclosed by? Okay. So I think there's some interesting things to talk about as far as what's going on with this region. For instance, it's hard to tell sometimes with the calculator, but right there is 0, 0. Do you really think that they're just intersecting right there at 0, 0, the two graphs?
Yes.
Not a rhetorical question. Hallie says yes. I heard a bunch of no's. Maybe a few silence. Try it out. How could you tell for sure? When x is 0,
Y is 0.
yeah, so with the cubic, for sure, it's just negative x cubed. So when x is 0, y is 0. But what about the sine, or what is it, 5 sine of... Yeah, sine of 0 is 0, so times 5, or square is 0, times 5 is 0. So I really think that 0, 0 is where this region stops. How do you think you could find where it starts, though? So this is 0, 0.
Try out -1.
I think you want to use the intersection finder on your calculator. So if you would, use the intersection finder, see if you can figure out what that is. I agree it's going to be like negative 1 point something. Looks pretty reasonable. Say it again.
0.2386. 1.23.
Negative though, right? Negative 1.2386. 2384. Let's go all the way with that. 238.
Sorry, 238, 648.
648. Do you guys agree with that for the x value of that intersection point?
Yep.
Yeah? Do we need the y value though?
Yeah.
What's the y value?
1.9003946.
Okay. Do you guys agree with that as well? Okay. So the question really becomes, which of these numbers is important to us, which of them is not? So go ahead.
I would just say the x, that's where you start and stop, it doesn't matter.
Can we talk about why that is? Because you're right. The x's are really going to be the only numbers here that matter. It is conceivable, though, in certain situations that the y's would be the things we would focus on. It is very possible. So what I'm going to do, kind of like the video you guys saw before, I'm going to attempt, I'm zooming way in here, I'm going to attempt to draw in a representative rectangle like this right here. Can you see that?
Yeah.
Turned out okay. There's my representative rectangle. What is the base length on that representative rectangle?
dx.
It's dx, right? The reason why I would say that is because to think about the base length, wouldn't we be going from like left to right, or right to left? Like it's a little itty bitty change in x. So this is a dx rectangle, and dx rectangles always accumulate from left to right. So like that. So from the left edge of the region all the way over to the right edge of the region. And so that's why we'll use the x's. Here pretty soon, I think we'll get to it today, instead of using a dx rectangle, like a tall skinny rectangle, we'll rotate it 90 degrees, and it'll be like a long and short, like a long, or like a wide, short rectangle, if you will. and that base length will be dy. So that would change things a little bit. We'll talk about that later. I just want you to know that it's not going to be, because I think as students and even as teachers, we want to use words like always. Always do it this way. And that would be misleading for me to say that, right? So please don't think of this as we'll always use the x values. At times we'll use the y values too. Okay, so let's think about how to set this up. How do I want to do this as far as my screens go? Did you have a question?
I was just wondering, so for this region, would the sine function have been considered the higher function?
Well, let's talk about that. Maybe we should. I was just debating on the screen here. I'll just use my calculator screen here because I know what the question is. You can obviously reference your notes. We're looking for the area of the orange region, right? So here's what we would do. We would say area equals integral from, where does this region start? Like, where do we start accumulating? That's right. So negative, be really careful about rounding here. So I'm going to write the whole thing, 38648. So we're going to accumulate from left to right. So we started there at negative 1.23. Where do we stop?
0.
When x is 0. That's right. So we go to 0 here. And then it's going to be high function minus low function. So you definitely can do the f of x minus g of x. I'm going to write out the whole thing here just because I'm on a different screen. But the f of x was what? 5 sine squared x
Square root
of 2x. So 5 sine squared of 2x, that is the high function on that region, minus the low, which was negative x cubed. Finish it off with dx. And that is the expression that you'd need to use to find the area of that region. What do you guys think? If calculator's active and you don't use Math 9, you're being silly, right? But if you are going to use Math 9, that right there has to be written down. Does that make sense? You really couldn't even do this, at least with the skill level we're at right now, couldn't even do this without a calculator. So anyway. All right. Any questions?
Well, since it doesn't need the, you just solve it, can you just write f of x minus g of x for your final answer?
Even if it wanted you to get an answer, you could still write f of x minus g of x.
Okay.
I just thought I'd write it out here simply because I wanted to clarify what the sine and the cubic being different to make sure we understood. But yeah, you can always use the f of x g of x name in lieu of the actual rule if you want. In fact, I think that's almost always best. Yeah, go ahead.
So on the region just to the left of the one we just did, would g of x then be the higher function?
So let's talk about that. So guys, can I totally wipe out this and say we're going to do like a totally different region? So let me just erase all this stuff. If they defined a totally different region, now I defined this region to be the region that was completely enclosed by, but you could define a whole different region, right? So you could say, we want to know, for whatever reason, we want to know the area of this region here. If I cut it off right there, and I maybe stop it right here, so it'd be this orange region right there. If that were the region, then yeah, the cubic would be the higher function, and the sine would be the lower function.
So it's just whichever.
Depends on where you're at. Yep, because those roles can switch depending on where you're at. Great questions from everybody. Happy to answer more if you've got them. Okay, moving on then. Let's check out, is the word total. That concept reminds me a little bit of total distance traveled-ish, although there's no absolute values really involved here. At least there didn't have to be. But I think when you see that word total, I think that should get you to think in a certain way. But I don't think there's any way we can really think about this other than throwing our calculator without a graph. So instead of throwing your calculator, use your calculator to graph these two functions, okay? I'll do the same thing.
I have a question, Mr. Anderson.
Go for it.
When would we apply this in the real world?
You already asked.
How many areas are there?
Okay. You guys getting a lovely graph sort of like mine? Okay. This, would it be fair to say that this graph is sort of like the one you just did, except instead of having one region enclosed completely, there are 2. Okay? So when you see that word I mentioned earlier, the idea of total area enclosed, then we're going to have to consider that there might be more than one region. There might be 2 or 3 or 4. Hopefully not a lot like that, but there could be multiple regions. So, and Ben, this kind of gets to your question, or maybe it was Drew's question earlier about what do you do if the high and the low switch? This is kind of that situation where I'm looking at 2 regions. I'll go ahead and mark them up here for you. Did you all see? Did you all see this region right here as part of the region that's enclosed? And then how about this one right here? So there's 2 regions totally enclosed, but on the 2 different regions, on one of them the blue is the high graph, the other one the red is the high graph. So we're going to have to take that into consideration. Are you guys, a lot of you guys are like busy pushing buttons on the calculator, which could be a good thing. Anybody want to explain what you're doing? Yeah, John.
So I separated 2 areas. So I first did the left bounded region,
Yeah.
and then I knew that f of x was over g of x.
Yep.
And then I found the 2 intersection points.
Intersection points, yeah.
Bound and right bound.
Yep.
It's like the,
Okay, so John, you're saying that you were working on essentially this first area. So I think what John brings up, kind of implicit in what he's saying, I think it's very important and a very good idea, is you kind of have to work on these 2 regions separately, right? They're going to be 2 separate integrals, and in the end, what are you going to do with the 2 separate values? Just add them up. That's right. Okay, great. So I would, just like before, I don't think there's any reason to use anything other than a vertical representative rectangle. So, whoops. Let's go with, man. So here's my representative rectangle. When it's tall and skinny like that, I would call it a DX representative rectangle. So we will accumulate across the shape from left to right. Can I get some intersection points? John, did you get this, this far left one?
negative 3.077.
118.
118. That's it? Okay. And that's x equals, right?
No.
And the other one is x equals negative 0.670.
Negative, say it one more time.
0.670.
0.670. Keep going.
I brought it.
1412.
You definitely want to have all of them.
And then you need the third one for the second one.
And you do need the far right one, so we might as well get that now, right?
I got 1.2958944.
I lost you after the 8.
944.
Okay. Let's double check and make sure those are right. We're finding all those intersection points so we know where the regions start and stop.
I had the same.
You got to say all 3 of those? Okay.
Why does my graph look so screwed up at that point?
Hey, again, I want to ask you guys, the question I think needs to be asked. As we go through and we find all these intersection points, you guys are all clearly good at that. You know how to use your calculators. It's awesome. Why are we totally ignoring the y values on those intersection points and only using the x's? No. There's a better reason. What's that?
The width of the rectangles would be dx.
Yes. So in other words, the width of the rectangle, in this case dx, tells you what all your other variables have to be. If the width is dx, that means everything has to be x's. If the width happened to be dy, then everything would have to be y's. You're not allowed to mix x's and y's. All x's or all y's, and the dx or potentially the dy tells you what you're supposed to use. Okay, so that's why we're ignoring all the y's. It's not that they're not important, ever. We just don't need them here. Okay. I think once we have all those intersection points, I think we're ready to set this thing up. So I'm going to focus on this left region first, and I'm going to say integral from negative 3.077118 We're going to accumulate from there all the way up to negative 0.67011412. So on that far left region, the blue function is higher. And was the blue function, we can use just the names of the functions, was the blue function f of x or g of x? The cubic? Yeah, the cubic was f of x. Okay, good. So I'm just going to write f of x minus g of x. I'm just using the high minus low convention that you learned in the video. That's our first region, right? And with the second region, all I'm going to do is add that to what I got for the area of the first region. So this integral will be a little bit different. What's going to be the lower limit? Like, where will we start accumulating for this other region? Wouldn't it be the same spot where we stopped on the other one? Yeah. So negative 0.67, yeah. Negative 0.67011412, and we'll stop at this other x value where the region ends. So 1.2958944. What's going to be different about the integrand compared to the first integrand?
Gx is now the higher function.
G of x is now the higher function. So g of x minus f of x dx would complete it. Okay, so did anybody take this all the way through Math 9? Mandy, what'd you get?
As a final answer?
Yep,
You want all the decimals?
just 3.
Okay, 21.359.
I did got 4 here too, but I rounded on the limits of integration.
So,
I didn't round either.
so that was not exactly what I was expecting, right? Should have been consistent. Sounds like it was inconsistent. So guys, girls, really important. When you put your limits of integration in, I tried to stay really disciplined here and put all of them. You should be putting the whole thing, right? Don't round. What did you guys get? Did you get the...
I didn't round at all, and I got 21.402.
Okay.
That's kind of what I was getting over here, right?
Yeah, I did.
And
I can confirm it was
402, 402 with no rounding. Mandy, it sounds like they're like really ganging up on you.
Yeah.
Sorry.
Sorry, guys. I didn't round. I used the wrong numbers.
Let's provisionally put it at 402.
I'm sorry.
Just double check. Hey, she stuck her neck out for you guys. Hey, I want to let you know something. I think this is really important because I feel like on an AP test or one of my tests, I think there's a tendency to be a little nervous about, gosh, what if I don't know what a graph looks like, right? What if I'm not sure how this function graphs? Really, for the most part, graphs are either supplied to you or the calculator will be active. So I don't think your ability to know exactly what a cubic looks like or what sine squared of 2x looks like, I don't think that should be the reason you do poorly or well. It should be what you do with it. It's going to cause you to do well or poorly. So please don't be too nervous about that. Okay, so we're trying to take this one all the way through to the end. Get it set up, no calculator allowed. Get an answer and see how it goes. Okay, let's see how you all did. By the way, I don't know if you guys can tell from the graphics, you'll start to get a little more familiar with the graphics, but this is right off of an AP test from several years back. So if you were successful with this part, know that at least on one FRQ, you could be like, I could do this, right? I can definitely be confident. Not just like falsely confident, but yeah, I can attack this thing and know that I can be successful. So here we go. Talking about region R, the area equals integral. Now they gave you a choice. It looks pretty clear, and I think you can tell from the functions that they do intersect at the point 0, 0. So did you guys all start your accumulation at 0? So the integral from 0. Did you guys stop at 2 or 4? 2. You're going to use... Hey, guys, hey, chit-chatters, stop. Thank you. Why did you ignore the 4? Because the 4 is a legitimate part of that location, right?
Yeah.
Why would you ignore the 4?
It's dx.
Because it's a dx rectangle, that's right.
Why did you know that it's dx?
I would love to talk about that.
Couldn't you do DY?
I was gonna, can I do that at the end?
Oh, yeah.
Yeah. So I was, based on what we've been doing so far, I was assuming you'd probably use a dx rectangle, and that makes perfect sense here. So, but I'll show you the dy in a second. So we're going to accumulate from left to right across the page, and as you go from left to right, it's true this rectangle will kind of work its way up the shape as well. So in this case, the high function would be the line, right? It's always the upper part of the representative rectangle, and so there's no switching around like we had before. So it'd be 2x minus x squared dx, and that's your setup right there. You can put the 2x minus x squared in parentheses if you want, or you can just leave it like that. Here's how it finishes. Antiderivative would be x squared minus 1/3 x cubed, evaluated from 0 to 2. So you would plug in your 2, and when you plug in your 0, you just get 0, don't you? 0 minus 0. That's kind of nice. So did you guys get an answer of 4 minus 8/3?
Yep.
So then it would be 4/3? Okay. Gentlemen, again, constant chatter, not very productive. Do you have any questions? I want to show you the dy way here in just a second. Do you have any questions at all?
That's my question. The dy.
Okay. So let's do this. Later on, you'll see why this would be a thought. Probably, realistically, didn't occur to you to do it this way. But here would be a whole different way to do it. Let's remember that our answer was 4/3. And this is a really good transition. We'll spend the last couple minutes of our class doing this, and then we'll actually start class next time with something similar to this. Okay? So here's what I'm going to do. Gentlemen, again, I suggest you pay attention. I think there was enough folks that asked questions. I think this will be a handy thing for you to know. So this one would have been a pretty easy one for me to do this with. So instead of me doing a vertical representative rectangle that is dx thick, I could have chosen, this one really could have gone either way, to do a horizontal representative rectangle that would no longer be dx thick. The thickness would now be measured almost as like a height. And then the base length would be the thing that varies, right? You see how down here at the bottom, that base length would be very short, right? And then here in the middle, it'd be pretty long, and then up here, it would be back to being really short again. But the thickness would be dy the whole time. Do you understand why we would call it a dy thickness instead of a dx? This little measurement right there would be a little itty-bitty change in height, which we'd measure on the y-axis, so it'd be dy. Does that seem reasonable? So here's how this thing goes. This gets pretty interesting as you go. Your ability to do this, I think, shows a lot of understanding. So instead of accumulating from left to right, like we do with a dx rectangle, we'll accumulate bottom to top. All these little representative rectangles would be filled in like this. So we'd accumulate from bottom to top, and we'd add up all the rectangles in that region. So when it comes time to set up your integral, you'd say area equals integral from where to where. Where would you start accumulating?
0 to 4.
0, and you'd end at 4. That's right. So you'd go from 0 to 4. And we do that because these are all dy little representative rectangles. So I'll put the dy out here. But then as far as the high and the low, this is where it gets a little weird. Because we've gone from a rectangle that is tall and skinny, and we've rotated it 90 degrees, so it's no longer tall and skinny, it's like short and wide. So now high and low don't make the same kind of sense. It's going to be, when you rotate things, it's not going to be high and low, it's going to be right and left. So it's going to be, you see how right is to left as high is to low? So I'm going to go right is to left. The right one was the parabola, right? I would be making a mistake if I did this, though, because everything has to be in terms of y because it's a dy rectangle. So what I have to do then is solve for x. So with this one here, it would be root y equals x. And with this one here, it would be y over 2 equals x. It's still going to be parabola minus line, because we're going to do right minus left, but it would be root y minus y over 2. So we're kind of,
Either one,
sorry, say again?
they'll accept X or Y method on these.
In one of these, this one could go either way. It really could. Others, one, like X or Y will be clearly the better choice.
Right.
As far as easiness of doing it. Hey, if you really care, some of you probably do, maybe hopefully all of you do, if you take this all the way through to the end, which we don't have time to do here today, you'll see you get the same answer of 4/3. So anyway, have a wonderful day. See ya. Great job.